after a season of torrid rains, cloudbursts, and floods across the country. India braces itself for a very stringent and a very cold winter season in 2025. Why does that happen? Welcome to another session and another episode of Geography Basics, where today we shall be covering the portion of La Nina and how this year's La Nina is expected to cause severe cold wave conditions across the parts of the country. So, in this particular video, we are going to discuss the basic phenomena associated with La Nina events, El Nino events. Why do they occur? What is the basic reasoning behind them? And also the aspect associated with their influence when it comes to Indian climate. This is one of the favorite areas when it comes to civil services examination, both for the prelims as well as for the mains examination. And during the course of this discussion, we shall also be taking a look at the previous year question which has been framed from this particular topic. So, without further ado, let us directly jump into the discussion of the topic about the colder winters that awaits India in 2025. Now, across the country, the climatologists have been bracing for an extremely cold winter climate in 2025. As the Pacific starts to cool down and the conditions of La Nina start to develop, the expectation is it will have an adverse impact on India in terms of the severity of winter that India experiences. As you can see, almost all the newspapers and all the news headlines have gobbled up the story that La Nina might develop by the year end, may bring colder winters in India. Now, when we say La Nina might develop by the year end, what does that mean? Now, these all events of El Nino, La Nina, and even the normal conditions of Walker circulation are basically an oceanic atmospheric influence and condition which develops in the region of the Pacific Ocean. Now, it does happen that sometimes during the same year, conditions change from La Nina to El Nino, and that condition prevails for a couple of years, and then again it can change from, let's suppose, El Nino to La Nina back again, or El Nino to neutral conditions, and that keeps on changing. So, this frequent changing of weather conditions in the Pacific, which in turn influences the global weather conditions, that is what is also referred to as ENSO or El Nino Southern Oscillation. Now, this ENSO basically stands for El Nino Southern Oscillation. Nino Southern Oscillation. Now, why is it referred to as El Nino and why is it referred to as Southern Oscillation? So, basically, the anecdotal story goes that the Peruvian coastline, which otherwise during the months of December, January, etc., they remain dry, during one of these years and during one of these months, it was expected and it was experienced by the fishermen that there was unseasonal rainfall. Now, the rainfall which occurred in the month of December, the fishermen considered it to be a gift from Christ itself because it was the month of Christmas. And that is where they considered this event, this anomalous weather event, as the Christ child, which translates into El Nino. That is why the name El Nino came into existence. Now, climatologists over a period of time understood that Peruvian coastline, that is the western coast of South America, otherwise remains dry during the summer season of the southern hemisphere, that is during the month of November, December, January, and so on. It remains dry, it doesn't receive that much amount of rainfall. But then, during certain years, after every 4 to 5 years or after every 5 to 7 years, there would be some instances where Peruvian coastline would start receiving rainfall during these months. That would be considered to be the gift from Christ himself, and hence the Christ child or El Nino. But then, because this event would be repeated every 5 to 7 years, and again after that, it would revert to the normal condition of dry season, that is why it was referred to as an oscillation. But why the term southern is associated? Southern here indicates the South Equatorial Pacific Ocean, where all these weather phenomena they tend to dominate, and all these influences they tend to dominate. So that is why the name ENSO circulation came into existence. At this point of time, the climatologists were not even aware about the condition of La Nina. It was only much later that they came to an understanding that yes, there are seasons which are dry in Peru. Sometimes it receives rainfall, but there are also certain seasons after every few years when the Peruvian coastline is not only dry, it is so extremely dry that it experiences or faces a drought like condition. That was termed as La Nina, or the opposite of the Christ child, that is the girl child. And that is where the term La Nina gets its origin from. So presently in the region of the Pacific, you have and South Equatorial Pacific, you have three conditions which dominate. You have the conditions of El Nino, then after maybe a few months, a few years, it gets back to neutral, and then sometimes it also changes to La Nina. Now 2024-2025 mostly has been the year for El Nino. That is why India has been receiving a kind of an unpredictable amount of rainfall. But then, later part of this year of 2025, the conditions are expected to change from El Nino to the condition of La Nina. That not only brings surplus amount of rainfall in India during the monsoonal season, but at the same time manages to make the winter season much more colder. So why does that happen? Let us understand the basics of this ENSO circulation. But before that, a couple of basic pointers for those of us who have no clue about how this ocean atmospheric telecommunication tends to happen. So, first of all, when we talk about ocean water, so any ocean water, particularly in the lower latitude around the tropics, around the equatorial region, if you consider the oceanic water, the only source of heating for the oceanic water is the solar insolation. The sun rays provide the source of heat. Now, what does that mean? That as the solar rays provide the basic amount of heating, the highest temperature will be experienced on the surface. So, surface temperature will in general consist of the warmer waters. So, surface temperature is high. And as you go into the lower levels, the water temperature reduces. What do we mean by that? So let's suppose at the region of equatorial Pacific, the surface temperature is around 26 degrees Celsius. As you go into the depth, the temperature will reduce to 20 degrees Celsius. Further lower that you go, it will reduce to 10 degrees Celsius because the solar rays are unable to penetrate beyond a particular depth. That is why the temperature starts to fall as you go into the depth of the ocean. But that also means that the warmest water is present on top. Now, another basic factor that you need to know is, let's suppose when you have an oceanic region, right? And if there are wind movements which are experienced across this oceanic surface and across the oceanic water, these winds, they will basically be able to carry the surface water along with them. I will show it to you with the help of animation as well. But these winds are able to drag the surface water. So, in a way, we can say that winds are able to drag the warmer waters. Winds drag warmer water. Okay. Now, what is the influence of it? We will look into it in greater detail. Now, before we move into the effect of the winds, a basic aspect regarding the pressure systems. Now, you have two types of pressure conditions. One is associated with a lower pressure condition, and another is the higher pressure condition. So, whenever any region is heated, heated area, heated region basically indicates a condition of low pressure. Low pressure becomes the attractor of the winds. Attractor of the winds. All the winds will blow towards the region of low pressure. And colder area, that becomes the region of high pressure, right? That is where the winds originate. Origin of wind. So, in general, whenever we talk about wind movement will always happen from a high pressure to a low pressure. Always. Wind movement occurs from a condition of a high pressure to a low pressure. Remember this with a simple sentence: wind always blows from a high to a low. So, wherever you have a lot of warm temperature, Wherever you have very cold conditions, the winds will blow from a colder region to a warmer region. That is the basic property of the wind. Now, all of this will be woven together in a brief mechanism if you just be patient enough for the next couple of minutes. Now, when we talk about the region of the Pacific Ocean, Pacific is quite unique, and you don't have any such place across the entirety of the globe. Because in the region of the Pacific, you have very large sea surface area without much of the land regions in between. Now, because you don't have any land region in between, that means what? The force of resistance which is offered to the wind, the frictional force which is offered to the wind, is very, very less. So, over water bodies, the wind speed gets very high. The wind speed basically becomes very, very high. Why? Because frictional force is less. So, from this, you have another kind of question, another kind of topic which can be asked in the examination. What is the topic? That wind speeds are normally higher in the northern hemisphere or southern hemisphere. The answer is wind speed is always going to be extraordinarily high in the southern hemisphere due to a lack of a distinct landmass. So, because southern hemisphere is dominated by water body, wind speeds will always be there. Now, then, when we talk about the region around the equatorial portion of the Pacific, let's suppose this is the equatorial region of the Pacific. Let's assume. Now, what are the winds, permanent wind systems, which are observed across the region of equator? Around the region of equator, you basically have the trade winds, both in the northern hemisphere as well as in the southern hemisphere. You do have the prevalence of the trade wind. Trade winds in general, their motion is where? Their motion is east to west. Always you will observe this phenomena to be present across the globe. Their entire motion is east. Now, as they are moving over the Pacific Ocean, their speed becomes extraordinarily high, very, very strong. Now, when the wind speed is more, they are able to drag more amount of surface water along with them. All that surface water is the warmer water. Now, where will the surface water accumulate? Surface water will start to accumulate in the portion of Western Pacific. So, under normal conditions where you have the movement of the trade winds, all the surface water starts to accumulate in the region of western part of Pacific Ocean. So, as a consequence, now if you can take a look at this graphic as well and this animation, you will observe that these trade winds, they carry out the surface water and they keep on dumping and accumulating the surface water in the region of Western Pacific. Meanwhile, in the region of Eastern Pacific, that is near the South American coastline and the Peruvian coast, as the surface water is removed, subsurface water which was colder, that rises up to replace the surface. Now that can be understood with the help of these animations. Now if you observe this, look, if you have a wind which is moving in a certain direction, it is carrying all the warmer surface water along here. Eventually, this warm water is forced to pile up and accumulate in this region. As a consequence, here the sea surface temperature increases. Whenever the sea surface temperature increases, it ends up inducing a condition of low pressure, right? Which means it will attract more winds. Meanwhile, this is what happens in the region of Western Pacific. In the region of Western Pacific, this is how the warmer waters are getting accumulated. But what happens in the region of Eastern Pacific? In the region of Eastern Pacific, as you will observe that the winds are dragging the surface water away, the cold subsurface water rises to the surface to replace it. So that means in this region where the colder subsurface waters have risen up, this is the region where the sea surface temperature becomes low. It becomes colder because the subsurface temperature is lower. So when the sea surface temperature gets lower, there is a condition of high pressure. So what it translates in the entire region of the Pacific Ocean is that when we talk about the western coast of Pacific, that is the Australian coastline, Indonesian and the Philippine coastline. Here, you have accumulation of warmer water and a condition of low pressure. Meanwhile, in the region, otherwise, here in the eastern portion of the Pacific, colder subsurface waters will rise to replace it, and you will have a condition of colder waters or a condition of high pressure. Now, winds always blow from a high to a low. So, the general wind direction will be from a high pressure to low pressure. The winds will reach this low pressure from all different sides. And as they reach this portion of low pressure, they will also get heated up because there is a region of warmer water. So, as they get heated up, these winds will also rise up. There is a kind of a convection. And as these winds rise up, they will lead to the formation of clouds in the region of Western Pacific, and they will cause rainfall in this entire area of New Guinea, in the region of the Philippine coastline, Australian coastline. Every region will receive a lot of rainfall. Meanwhile, after that, the winds will diverge in different directions. And here, when they diverge, they will be sinking in the area of the high pressure. This sinking wind or the sinking air column will not allow the cloud formation to happen in the Peruvian coastline. And that is why Peruvian coastline will be very dry in nature. This is the normal condition which prevails around the entirety of the Pacific Ocean. This is what is also referred to as a Walker cell or a Walker circulation, named after one of the most brilliant climatologists who have lived in the past couple of centuries, that is Gilbert Walker. A factual trivia: Gilbert Walker eventually became the head of Indian Meteorological Department in the time of the British era. So he was so famed in terms of his climatological prowess. So this is the condition which prevails under normal circumstances in the Pacific Ocean, which means under normal circumstances in the Pacific Ocean, the region of Australia, Indonesia, and Philippines will receive a lot of rainfall, whereas the Peruvian coastline and the western coast of South America will remain very, very dry. So that is the condition which is referred to as the Walker circulation or the neutral condition in the case of ENSO cycle. So we know that in ENSO cycles you have three phases: El Nino, La Nina, and neutral. So this is the condition of the neutral circulation. Okay. Now, so the flow chart for your revision: what happens during the Walker circulation? Trade winds blow from a general direction of east to west. These winds blowing over the vast expanse of the Pacific, they gain a higher speed. Why? Because the frictional force is very, very low. These trade winds, they tend to drag some amount of surface water along with them. Faster the speed, more amount of surface water will be dragged by these winds. Now, these surface waters are warmer due to the solar radiation, and that is where they create a condition of low pressure in the region of Western Pacific Ocean. However, when you have these conditions of low pressure, that has its impact in the other oceanic regions of the world as well. If you take a look at this image indicates to you that here this is the region of the Western Pacific. This was the condition of low pressure. This is the normal Walker circulation. Observe how it will have its influence even in the southern equatorial Indian Ocean, in the region of Africa, and so on. So it has got its impact across the climate of the world, and it has got its impact even on the Indian subcontinent. During these conditions in India, India either receives normal amount of rainfall during the monsoon months or slightly above normal. Okay, slightly above normal or normal amount of rainfall is received by India during these months. Having said that, oftentimes these conditions, they further get strengthened, and that is when you experience the condition of La Nina. How does that happen? And what is the phenomena of La Nina? So understand this. Under neutral circulations, you have a low pressure here, and you also have a high pressure here. So the trade winds, they move from high pressure to low pressure, and they rise up, isn't it? Now, think about it logically. When the trade winds they are moving across the surface from high pressure to low pressure, they will drag more amount of surface water along with them. More surface water will be dragged, and surface water is warmer. That means the pool of warm water will grow larger and larger. When the pool of warmer water will grow larger and larger, means what? The low pressure will get intensified, the temperature will increase, so the low pressure will become very intense. When the low pressure becomes intense, more winds will be dragged. More winds will be dragged means what? More surface water will be brought over. That means in the region of Eastern Pacific, there will be more subsurface water coming up to the surface or more upwelling which will happen. So the high pressure will also get strengthened. As a consequence, the entire cycle becomes much more stronger. So that condition is as La Nina. How do we understand this? So take a look at this particular animation. And I will also give you a mind map which you can use to understand this. So wind movement in general, wind movement from east to west, east to west, isn't it? Now, when you have low pressure, where? Western Pacific, Western Pacific means what? Attracts more winds, attracts more winds. Now, these winds will have the capability to carry more amount of surface water, carries more surface water, right? Now, surface water is the warmer water because the solar insolation heats the surface directly, right? So, carries more surface or more warmer water. Now, as a consequence of this, what happens when you have more warmer water which is carried over? That means the low pressure will get intensified, more warmer waters in Western Pacific, in Western Pacific, Western Pacific as in the region of Australian coastline. Now, when more warmer waters occur in the region of Western Pacific, winds get stronger, isn't it? As these winds get stronger, as a consequence of that, more surface water will be dragged from Eastern Pacific as well. More surface water dragged from Eastern Pacific. Okay. Now, when more surface water is dragged from Eastern Pacific, what does that lead to? That basically means you will have a condition where more upwelling in the Eastern Pacific. Upwelling means subsurface water coming to the surface. More upwelling in Eastern Pacific. Now, as a consequence of that, high pressure in the Eastern Pacific gets strengthened in Eastern Pacific, isn't it? When the high pressure gets stronger, low pressure gets stronger. What does that mean? That basically means wind speed gets higher. Wind speed becomes higher, isn't it? So, as a consequence, they will carry more surface water. So, the entire cycle becomes much more stronger. Now, during this condition, the Australian coastline, which was earlier receiving rainfall, will now receive such high amount of rainfall that flooding conditions can be observed or can be experienced. These can be areas of Philippines, Indonesia, the region of New Guinea, the region of Australia, that is the Eastern Australia. They will be experiencing very heavy amount of rainfall, almost to the condition of flood. Whereas the region of Eastern Pacific, that is the Peruvian coastline and South American coastline in general, they will have a very strong high pressure. During high pressure, you have sinking air, no cloud formation, no rain. This is nothing but a much stronger Walker circulation. That is why whenever we talk about La Nina condition, it is referred to as a strengthened case of Walker circulation or a Walker cell. Okay, it is much more stronger Walker cell. Now, as you can see, all the warmer waters, they are basically being carried to the region of Western Pacific. This is the satellite imagery taken over multiple days. So as a consequence, you will observe that here the warmer water pool is increasing, right? Now, this becomes very, very intense low pressure, sometimes initiating some amount of typhoons and willy-willies in the northern and the southern hemisphere, respectively. Typhoons and willy-willies are nothing but the tropical cyclones which generally develop over the oceanic water body. So that is the region of the low pressure that you encounter. So this is the La Nina condition. So during La Nina conditions, significant low pressure develops across the western equatorial Pacific Ocean, while an intensified high pressure develops over eastern equatorial Pacific Ocean. In a way, it is nothing but an intensified Walker cell. Conditions across northern Australia are very similar: flood, heavy rainfall, whereas drought like conditions across the region of South America. Now, La Nina conditions, they are positive for Indian monsoonal rainfall. However, there are certain changes which do happen in the region of Western Pacific. So as you can see, in the Western Pacific, all this warm water is pushed into the region of Western Pacific. So Western Pacific experiences piling up of warmer waters, right? Piling up of warmer water. What do we mean by piling up of warm waters? So all these vents basically push in more amount of warm water. As a consequence, there's a slight change even in the sea level, where the sea level in the Western Pacific gains a height gradient almost around 8 centimeter to 10 centimeter. They gain a height gradient, or all that water is accumulated. Now the water doesn't flow back because it is supported by the trade winds. And these trade winds keep the water accumulated. That is the condition of La Nina. If you observe the circulation, there is a circulation which happens across the equatorial portion of all the oceans in general, and it impacts countries like India quite significantly. During the years of La Nina, India has also witnessed rainfall which is almost 110% as compared to what the average rainfall would have been. So these are the conditions of very heavy and intense rainfall in India. Now, here in the region of the Pacific, you can expect it and you can observe it that there is massive level of upwelling, which brings cooler waters and colder waters to the surface, while all the warmer waters are accumulated in the region of the western. But as you can see, the case of upwelling is prominent not only in eastern Pacific, but even in the central Pacific. You have colder water. So that is why La Nina conditions are also what are referred to as the cooling phase of Pacific. Cooling phase of Pacific Ocean. Okay. So till now, we have seen what is the condition of Walker circulation. We have seen what is the condition of La Nina. So two parts of the ENSO cycle we have covered. During the condition of neutral circulation or Walker circulation, this is about normal rainfall or slightly above normal rainfall that India will receive. But during the conditions of La Nina, India always receives excess amount of rainfall during the monsoon. But then there are other influences as well. So when we talk about the influence on Indian climate due to the conditions of La Nina, so what are the influences? During monsoon, this basically increases the amount of rain, increases the rainfall, right, in India, leading to flood conditions in many of the districts of the country, in many of the regions of the country. Now, why do the monsoons become stronger? That is owing to the strengthening of the southern trade winds across the northern Indian Ocean. The details of that is not required for your basic understanding. But then, why will it make the winters colder, or how will it influence the winter season? So, during the winter months, the temperature becomes lower. Becomes lower. How? So, for this, you have to understand the transition or the aspect of the jet streams. Here, the role of the jet streams come into place. Now, over the Indian subcontinent, you have the presence of a permanent jet stream that you can see in the image here. This is the jet stream. This is what is also referred to as the subtropical westerly jet stream. Subtropical westerly jet. Okay. I will write it down in detail also. That is your subtropical westerly jet. Okay. Now, this subtropical westerly jet, it basically is present over the Indian subcontinent prominently during the winter months. During the summer months, this jet stream transitions northward. As this transition northwards, it allows the moist winds from the Indian Ocean to come over to the Indian subcontinent, bringing monsoonal rain. But during the winter months, this area or this jet stream sets prominently over the Indian subcontinent. Now, during the winter months, you have very cold winds originating from the region of Siberia, the Siberian High. Now, these cold winds are restricted by the jet stream. The jet streams don't allow the warm winds and the cold winds to exchange each other. They form a kind of a barrier. In order to understand it pictographically, think about a situation where, let's suppose, you consider the ground surface, the cross sectional view of a jet stream here. Let's suppose this is your subtropical westerly jet, which is moving like this over a region, right? So, if you have warmer air here, warm air, and if you have colder air here, it won't allow the warm air to come in the region of the cold air, neither will it allow the cold air to come into the region of the warmer air, because this forms a kind of a natural barricade, right? It forms a kind of a natural barrier for the winds, barrier for wind. So, till the region where the jet stream is present, that is the area till which you will have the colder air. And that is also the extent till which you have the warmer air. Let's suppose subtropical westerly jet stream is moving in this direction. Now, what happens during the La Nina years? During the La Nina years, we have seen you have an intense low pressure which develops over the region of Western Pacific. So, here you have a very strong convection, rise of air. How this rise of air influences this jet stream becomes the reason why the winters will get colder. As this rise of warm air tends to happen, this jet stream shifts slightly to the south. So there is a southward migration of this jet stream. As there is this southward migration of the jet stream, what the colder winds originating from the area of Siberia, they are now able to penetrate into the region of the northern part of the country. As a consequence, the northern part of the country, that is the region of Jammu Kashmir and the area of the Himalayas in general, they will be experiencing much colder winds, dipping the temperature. At the same time, as these jet streams basically get prominent over the north central part of the country, they also carry out along with the westerlies, lot of cyclonic disturbances which develop over the region of the Mediterranean. They even start developing over the region of Afghanistan, Pakistan, and these are your western disturbances. These are your traveling low pressure systems which hits India in the region of the north. So as this hits India, in the mountainous areas, it will cause a lot of snowfall. So Jammu Kashmir will experience a lot of snowfall. Himachal Pradesh will experience a lot of snowfall. Uttarakhand will experience snowfall, whereas Punjab, Haryana, Delhi, northern Rajasthan, Uttar Pradesh, all these areas will experience very high amount of rainfall. Why? Because these are traveling low pressure systems. These traveling low pressure systems include a lot of moisture within them because they are formed as a combination of warm winds and cold winds coming together, now bringing all the moisture from the nearby seas and dumping them over India. Now think about it. During the winter months, when you have more amount of rainfall, does it make winters warmer? No. Rainfall in winter always makes the winter much more colder. Cold wind starts to blow from the mountains to the plains. You have a condition of a cold wave. So, as a consequence, during the winter months, you will experience the presence of cold waves, right? So, cold winds start moving, cold winds in northern India. Now, why do you have cold winds in northern India? Due to the southward migration, due to southward migration of jet stream. Which jet stream? That is the subtropical westerly jet stream. So that allows the cold winds. Where do the cold winds originate during the winter? They originate from a high pressure in the region of Siberia that is also referred to as Siberian high. Right? So because of these cold winds, you have lowering of temperature. But also during the winter months, when you have occurrences of these Western disturbances, now Western disturbances become more frequent. As they become more frequent, means what? They will basically hit the Indian subcontinent more frequently within every 3 to 4 days. So that means more snowfall in Himalayas. Now, snowfall in Himalayas will always make the winters colder. More snowfall in the region of the Himalayas, isn't it? And along with that, you will also have winter rains in northern plains. Rains in northern plains. Okay? Both of these phenomena will become very prominent. As a consequence of this, North India starts to experience cold wave, which slowly and steadily will spread across to southern part of India as well. There is another factor involved. That is, when you have this jet stream which is moving over the central portion of Indian subcontinent or northern portion of Indian subcontinent, because they don't allow the mixing and the rise of the air, that means during these conditions you will also have clear sky. Whenever you have clear sky after rainfall, if let's suppose clear sky comes, whenever there is rainfall brought by the western disturbances, it will increase the colder condition. But then, after the rainfall has passed, there will be clear sky. Whenever clear skies are there, during the winter, the nights are longer. So the amount of heat lost by the terrestrial radiation is also very high. So loss of heat is very high from the surface. Okay. That basically becomes very, very high. So that means ground gets much cold. Ground gets cold. Please understand this. Whenever you have clear skies, heat loss will be so high. That is why you would experience that during the cloudy nights, it is still warmer. But during the clear skied nights, you will always observe fog formation, right? During the winter, because the loss of heat is very high. That is why clearer nights are colder as compared to the cloudy nights. During cloudy nights, you don't even observe dew formation. But during the clear nights, you will always observe dew formation in the winter months. So that is, these are the three reasons why the winter becomes colder. First reason, because of the southward migration of the jet stream, allowing more cold winds from the Siberian high. Second reason, because of the southward migration of the jet stream, you will have more such low pressure from the Mediterranean Sea being carried by the westerly winds over the northern part of India. So more frequency of western disturbances will always lead to greater amount of rainfall. And then clearer skies because of the jet stream will also mean loss of heat will be substantial. So because of these three reasons, the temperature in North India dips quite substantially, and as a consequence, the entire country starts experiencing cold waves. But then, here, let us take a look at the question which was asked in the examination, prelims examination. La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in the equatorial Pacific Ocean. El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on the monsoon. Take a look at these statements. After the entire lecture of El Nino also, let me know what the correct answer is in the comment section below. Let's see how many of us are able to get this correct. Now, then you have in the ENSO circulation, we have considered the condition of La Nina. We have considered the condition of normal Walker cell. You also have a condition of El Nino. El Nino or the Christ child. Now, during this case, we have seen in the anecdotal story itself that the Peruvian coastline would receive rainfall, which would be rare. Now, as the Peruvian coastline would receive rains, that would basically bring about prosperity during those months, increase crop productivity. But simultaneously, now Australia would be receiving drought conditions. But why does this El Nino event happen, and what is this event of El Nino? To understand this, understand the basic phenomena and a kind of a homemade experiment here. So, for example, let's suppose you have kept a bucket. You have filled the bucket with water right up till the brim. And let's suppose you have started a table fan, and that table fan is blowing wind. Now, what will happen here? The bucket, all the water will get accumulated on one end due to the wind, and water will get spilled over as well. There will be a lot of accumulation of this water, right? Now, let's suppose you switch off the fan or you cut the supply. The wind movement will stop. As the wind movement stops, what do you think will be the condition of the state of water? Will it still be piled up on the other end of the bucket, and will the water still keep on falling from the other end of the bucket? No. All that piled up water starts to flow back. Something very similar is experienced in the condition of El Nino as well. See, even during the normal circulation, that is the Walker cell, and even during La Nina, all the warmer water was present in the region of Western Pacific. Now we have seen that the water level increases by 8 to 10 centimeter in the region of Western Pacific. But then this piling up of water is supported by the continuous movement of trade winds, isn't it? Take these trade winds as the case of the wind coming from the table fan. Now, during the heating of the Pacific, due to heating of the Pacific, when the Pacific gets very hot. So, during this time, the pressure systems which drive the trade winds, they get weak, right? So, as a consequence, trade winds become discontinuous or weak, weaken or stop temporarily, just like switching off the table fan. Now, when the trade winds stop or the trade winds become very weak, what happened in the case of the bucket? All the water flowed back, isn't it? So, as a consequence, here also across the Pacific, water flows back from west to east, Western Pacific to Eastern Pacific, isn't it? Now, this water was warmer, right? All this water was the warm water, which was the region of the low pressure. Now, because the trade winds they get weaker, all this warmer water starts to flow back. Now, the warmer water has accumulated itself in the region of Eastern Pacific. So, this becomes a region of low pressure now. As a consequence, the winds will be attracted towards the low pressure. Why? Winds always blow from a high to a low. So a low pressure region becomes the attractor of the wind. So this time, all the piling up of warm water will tend to happen in the region of the Pacific Ocean. Whereas there will be upwelling due to the wind movement in this area. Colder water will come, subsurface water, colder, which is, it will come to the surface. So you will have the creation of a high pressure. Right. So as a consequence, the wind movement that you will experience, the wind movement will be towards the region of the low pressure. The winds will now rise up, form clouds. They will cause a lot of rainfall here, and then they will divert and they will sink. So that is where, during these conditions of flow back circulation, you will observe that Eastern Pacific, that is the Peruvian coastline, now will receive rainfall, whereas the Western Pacific will become drier. This is the condition which is known as El Nino, right? So during El Nino, whatever was the case in the Walker cell, whatever was the case in the La Nina condition, that tends to get reverted. So earlier, during the Walker cell, we had observed that this low pressure was present where? In the Western Pacific. Now this low pressure system has shifted east. So that is why El Nino is also sometimes referred to as the eastern flow or movement, eastern movement of the Walker cell, of Walker circulation. Okay, eastern movement of Walker circulation. During this condition, Australian region will receive very dry drought-like condition. Now, because this peaks during the southern summer months, that is the summer of the southern hemisphere, oftentimes Australia during these summer months also experiences bushfires and wildfires, creating a lot of damage. Now, El Nino, overall due to the circulation which is induced here, observe that the region of warmer waters in the Pacific tends to increase. In the case of La Nina, if I can show you the image of La Nina once again, so you will find that the region of colder water had increased during La Nina. That is why cooling phase of Pacific. But during the condition of El Nino, you will observe that the warmer water pool increases in the region of the Pacific. So that is why El Nino is also known as the warming phase of Pacific. Okay, warming phase of the Pacific Ocean. During these conditions, India tends to receive very dry condition, drought-like condition. So it is detrimental to India in terms of crop productivity during the monsoon season and makes India much more drier. So you basically have lower water flow during the in the rivers also because of less rainfall. So you face water scarcity, you face irrigational challenges, and also the dams in quite often times they are much more empty. As a consequence, the energy or the electricity generation also suffers during the El Nino year. Earlier, El Nino and La Nina events used to occur once every 3 to 5 years. And then it would revert to normal. Again, after 3 to 5 years, you would have a condition of El Nino or La Nina. But due to climate change, the heating and the cooling conditions have become much more frequent. That is why nowadays you experience every other year either El Nino or La Nina. So due to climate change, the influences that these cycles they become much more faster, bringing about climatic uncertainty, regions or periods of excess rainfall, and periods of very dry condition also tends to follow. So impact over India, a very quick recap. If we take a look at the impact over India during normal cycle or during La Nina, what is the impact? Then during neutral cycle, what is the impact of India in terms of rainfall only if we consider, and during El Nino, what is the impact? So La Nina, you will have high rainfall, high amount of rains. Okay. Then neutral, you basically have normal or above average rains over India during the monsoon months. Okay. And during El Nino, drought or dry condition over India as well. And very briefly, again, if we were to recap, what happens during La Nina years? Winters also become cold. Why? Because of three factors. The first factor, the southward migration of the jet stream allows the Siberian winds, the cold winds from Siberia, to come up till the northern and central part of the country, lowering the temperature. It makes the phenomena of western disturbances much more frequent, which brings more additional snowfall and rainfall during the winter months. That means more colder winds will come from the snow packed Himalayas, and that will lower the temperature and lower the mercury level in northern Indian plains, making the winters colder. Thirdly, the presence of this stronger jet stream also means that you have clear skies otherwise, which means the loss of heat is also much prominent. And because the night time is also longer, so the period where you gain heat during the daytime is of shorter duration. The period when you will lose heat during the night time is of longer duration. So that is why nighttime tends to become much colder, and overall during the winter months, Indian region becomes. So in this particular entire session, what have we taken a look into it? What happens during ENSO cycles? Why winters become cold? What is the Walker circulation? What is upwelling and downwelling condition? Why the low pressure develops over the region of Western Pacific? Why the high pressure develops over the region of Eastern Pacific under normal circumstances? How that can intensify into La Nina? How the reversal of that happens during the heating of the Pacific due to the weakening of the trade winds, and there is a flow back or the counter equatorial current, which basically generates the condition of La Nina as a or generates the condition, pardon, of El Nino. So basically, when you have warmer waters in Western Pacific, Walker cell normal condition. More warmer waters, strengthened Walker cell La Nina. Warmer waters in Eastern Pacific, condition of El Nino. During Walker cell and La Nina, rainfall is received in the western part of Pacific, that is Indonesia, Philippines, New Guinea, and Australia. They experience floods during La Nina. During El Nino, all these islands, that is Philippines, Indonesia, and even Australia, they receive dry conditions because of high pressure sinking. Whereas when you talk about the eastern part of Pacific, that is the Peruvian coastline, they will always experience the rainy conditions, which makes the agricultural condition and agricultural season much more productive. So that is all that you need to know. Take a look at the previous year question and let us know the answer in the comment section. I hope this video has been helpful to you and has added some amount of basic concept to your already existing knowledge set. If this has been helpful, put that in the comment section and click on the like, share, and the subscribe button. We meet again with another session of Geography Basics. Till then, do take care of yourself. Goodbye. Thank you.